In this video, we will going to take up one more problem on projections of solids. How to solve this, how to analyze and solve this problem by using the sketchbook. The problem reads as a hexagonal pyramid, 25 mm sides of base and 50 mm axis length rests on HP on one of its edges of the base. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees and VP at 30 degrees. To do this problem, so first, since it is resting on one of the edges of its base, make that base edge perpendicular to VP. So this will going to be the initial position. So you can see one of the base edges, that is AF, and here since it is a hexagon, the base opposite to this is also a base. So you have one base edge here and the other one base edge is here. So since both the edges are perpendicular to VP, so I can rest it on this or on this. Now you can see here all the edges of the base is parallel to HP, therefore you are getting the true length in HP. So what is the length of the true length of the hexagon? It is 25 mm. So then here, how many triangular faces are there in this hexagon? You have 6 triangular faces. One it is OAF and OCD. Similarly, OAB and OBC. Similarly, ODE and OEF. So this is one more triangular faces. So here, this triangular face, the base edge is A dash F dash and this base edge is C dash D dash. So when you see from the top view, A, B, C, D, E, F all are visible. So O is near to the observer, so O is visible, and OB is away from the observer, so it becomes invisible. Therefore, you are keeping it in bracket. Similarly, as you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible. DEE, DEF is away from the observer, therefore D dash, E dash and F dash is invisible. O1 dash is hidden by the edge of AB and BC, therefore O1 dash is invisible. And here, as you look from the front view, you can see the height of the pyramid, so you will going to get the height of the pyramid as 50 mm. So how to draw this by using manual sketch? First, we need to write the XY line and you mark VP and HP. Then, since it is resting on HP, so obviously I need to start the problem from the top view. So first what I need to do, I need to construct a hexagon such that one of the base edges is perpendicular to the VP. So to do that, first I will consider any point. By using the compass, you take a radius of 25 and draw a circle. And you draw this vertical line. This vertical line will going to intersect the circle at 2 points, which becomes one point here and the other one point is here. So that becomes the diameter of the circle. So again with the same radius of 25, with this as center, cut it on this side and also on this side, on the circumference of the circle. Similarly, with this as center, P as the center, cut it on this side and also on this side. So now we need to mark the points. So to do that, I will take A, B, C, D, E and F. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. Then join between A to D with a dark line, similarly from C to F with a dark line and from B to E with a dark line. And all these 3 lines will going to intersect at these 2 points and we mark that point as O and O1 in bracket. Now, since the height is been able to see in the front view, so from the XY line, you measure a distance of 50 and draw a horizontal line, which should be a thin line. Then draw a vertical projector from AF to the XY line, from BE and then from OO1 to the XY line and then extend till to the 50 mm line. and then from CD project this to the XY line. As you look from the front view, ABC is near to the observer, so A dash, B dash, C dash, you write without bracket, and DEF is away from the observer, so D dash, E dash, F dash with the bracket. Then O1 dash is also invisible because it is hidden by the edge AB and BC. And O dash is visible because this is the extreme point or the apex point of the pyramid. As you see here, we have joined between OA, OB, OC, OD, OE and OF. Similarly, I want to join between O dash to A dash with a dark line, O dash to B dash with a dark line, O dash C dash with a dark line. Since you have joined between A to B and B to C in the top view, therefore you join between A dash to B dash and also from B dash to C dash. Then O to A, O dash A dash is visible to visible is visible, you dark that. O dash B dash is visible to visible is visible, you dark that. O dash C dash is visible to visible is there, you need to dark that. Similarly, A dash to B dash, which is visible to visible is visible, and B dash to C dash, visible to visible is visible. Therefore, you are going to get O dash, A dash and C dash and O dash with a dark line. Similarly, O dash, B dash is also with a dark line. So this is how you will be able to write the initial position, top view and front view of the object or the solid. Now, so as you see that one of the edges is resting on HP, you make that edge which is the edge which is perpendicular to VP in the top view. So that means this CD is the one which I am resting it on HP. You take any convenient distance from C dash, D dash of the first position front view to this. You only take any convenient distance and you mark that point as C dash and D dash in bracket. Once you do that, since I want to incline the angle with respect to HP, that is the axis line is inclined to HP at 45 degrees, therefore here I need to rotate the base by an angle of 45. Therefore, both these angle will make you 90 and this angle will be 90. So the total will be 180 degrees. So with C dash D dash as center, by using the protractor with reference to the XY line, you measure an angle of 45 degrees to the base, that is from XY line towards the left side. Then you draw a line which is an inclined line of 45 degree line. Then you measure the distance from C dash to A dash. From C dash you cut an arc on this and you mark that point as A dash and F dash in bracket. Then similarly you measure the distance from C dash to B dash. So from C dash you cut an arc on that 45 degree line. Then through this line, through this A dash C dash line with B dash as center, measure an angle of 90 degree with respect to this A dash C dash and draw a perpendicular. Then again you measure the distance from O dash to O1 dash. From O1 dash you cut an arc on this perpendicular line. You mark that point as O dash. Then rewrite the same sketch here without altering any view. That is O dash to A dash to C dash to O dash is one view. Then from O dash to B dash you make it the other one, the edge. So this is how. Now I need to write the top view for this. How to do that? Draw a vertical projector from A dash and M dash and draw a vertical projector from C dash and D dash and draw a vertical projector from O dash to the top view. Then as we have projected A dash, F dash and also C dash, D dash, draw a horizontal projector from F and D and extending it to the top, second position top view. Similarly from AC, you draw a horizontal projector till you get to this point. Okay, now you got these 2 points. Similarly, you draw a vertical projector from B dash, E dash and O1 dash and draw a horizontal projector from E to get this point, E. Similarly, you draw a horizontal projector from O1 to this and draw a vertical projector from this. You mark this point as O1 and then join this with a big dash and small dash line. Then you similarly draw a vertical projector from C dash and D dash and draw a horizontal projector from C and D. Both these 2 points will going to intersect at these 2 points. You mark that as C in bracket and D is in bracket. Then draw a horizontal projector from E and B and draw a vertical projector from B dash and A dash and passing through the point of O1 which is in bracket. Then once you do that, here you got all the points. Now I need to join them. So to join them, join between A to B, B to C, C to D, D to E, E to F and F to A with a thin line. Don't dark them. Similarly, join between O to A, O to B, O to C, then O to D and O to E and O to F. So this is how I will be able to write the second position top view and mark those points as A, B, then C is in bracket and D is in bracket, E and F and then this is O. And once you do that, now I need to write the condition of visibility. All the exterior edges of the boundary of the solid are visible. What does it mean? Let us start from AB. AB, the edge is on the boundary, then BO, EO, EF and F to A with a dark line because all the exterior edges of the boundaries of the solids are visible. The edge nearer to the observer is visible. Which is the edge which is near to the observer? O dash O dash, A dash, F dash is the triangular face which is near to the observer. As you look from the top view, O dash, A dash, F dash is the triangular face which is near to the observer. It is visible. How do I know that it is a triangular face? The top view of O dash, A dash, F dash is O, A, F which is a triangle. So that is visible. So you dot between these three. Okay. Once you do that, the edge which is on XY line in the front view is always invisible in the top view. Which is the edge which is on XY line, which is C dash and D dash. That will going to becomes invisible. So that means you put this C and D is in bracket. Once you keep this C, D is in bracket, then invisible point to invisible point is invisible. Okay. The next thing is, from a point, if any one of the edges is invisible, automatically all other edges from that point are invisible. What does it mean? If you see that C dash, D dash is the hidden edge, then what happens? From D dash, you have D dash to C dash, then D dash to O dash, then D dash to E dash. That will be invisible according to the condition of visibility. Therefore, you have to keep that D dash, D and O and DE and DC, then CO and BC. All these edges automatically becomes invisible. So now, since some portion of the hexagon becomes invisible, therefore O1 is in this and you are going to keep it in bracket. Then, this is how you will be able to write the views for the second position top view. Now we are going to take up the third position. Now once you do that, then the axis which is inclined to HP at 45 degree is inclined at 30 degrees to VP. So So that means once the axis becomes inclined at the 45 degrees to HP, so what happens to that distance in the front view, top view? That is apparent length. But the inclination given is here true length inclination. So therefore, I need to convert this true length. I need to convert. Therefore, I need to convert the true inclination which is there onto apparent inclination, and to convert that I need to find out the apparent inclination. Why do I need to find out the apparent inclination? Because once the axis becomes inclined to HP, you will going to get the apparent length in the top view, that is the second position top view. And since I want to rewrite the second position top view here, so therefore I need to find out the beta inclination of the axis. So to do that, first I will consider any point, and then from there I will draw a horizontal line. Then with reference to that horizontal line, by using the protractor, you measure an angle of 30 degrees and you draw a inclined line. Then by using the compass, since it is the true inclination line, for that you need to take the true length of the axis. What is the true length of the axis? Is 50 mm. You consider any point on that 30 degree line and you mark that point as O. From that point, by using the height as 50 mm, you cut an arc on that 30 degree line. Then draw a horizontal projector from there. Once you do that, I need to find out the beta inclination. So to do that, you have, once the axis becomes inclined, you have O1 which is reduced in length. By using the compass, with O as center, take the radius of O1 and from the same center O, cut on the locus line which is drawn. So now you mark that point as O1 in bracket. Then by using the compass, you measure the distance from O to this point. Similarly from O, you mark that point here. Then with reference to O1, you draw a perpendicular. Then you measure the distance from this point to C and also from this point to D. Both will have equal distances. So similarly, you transfer from this towards the right side, that is towards the left side, and also onto the bottom side. As we see here, as you rotate in counterclockwise direction, A is here, then B should come here. So therefore, what I need to do, through O1, with reference to O1 line, you measure an angle of 90 degrees and draw a perpendicular to O1. Then you measure the distance from this point to B and also from this point to E, and transfer it from this point to E and also from this point to B. Once you do that, so you have got this section. Similarly, you measure the distance from O to this point. From O, you transfer it on this side. Once you get that point, to this line, you have this line as perpendicular. So from this point, you measure an angle of 90 degree with respect to the beta inclination line and draw a perpendicular. Then you measure the distance from this point to C and also from this point to D, and the same thing is been transferred from here to here and also from here to here, and you mark those points as D in bracket and small e is in C is in bracket. Then you rewrite the same sketch, whatever it is written here, the same thing including the views, you reproduce the same thing, but only the condition is it should be written that the second position top view is written on the third position top view by looking at on the apparent inclination line. So once you do that, now I need to go for writing the front view. So to do that, draw a vertical projector from O to the front view and draw a horizontal projector from here. These two points will going to intersect at this point. You mark that point as O dash. Then similarly, draw a vertical projector from both A dash and F dash and draw a vertical projector from A and also from F. So these two lines will going to intersect at these 2 points. You mark that point as A dash and F dash. Similarly, you draw a horizontal projector from B dash and E dash and draw a vertical projector from B and also from E. So both these two lines will going to intersect at these 2 points. You mark that point as B dash and you mark that point as E dash. Similarly, C dash D dash is on XY line. Therefore, draw a vertical projector from both C and also from D. Both these two lines will going to intersect on the XY line. So once you do that, we have projected all the points which was taken from the second position front view to the third position. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash and F dash to A dash with a thin line. Then join between O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash and O dash F dash. Then join between O dash and O1 dash. So now, once you do that, all these things has been written by using thin lines. Now I need to dark them because which is the one which is visible unless and until you write the position arbitrarily or you write the position according to the requirements of the problem. And once you do that, now I want to write which is the condition which is visible and invisible. So only when you join the points with the thin lines, then only you will be able to make out which is the boundary line and which is not the boundary line. So what is that exterior adjusted boundaries of the solid? Means what? The extreme points which is passing on each of these sides is the exterior adjusted points or exterior adjusted boundaries of the solid. So that means join between O dash A dash because that happens to the exterior adjusted boundary. Similarly, from D dash to C dash and C dash to B dash and B dash to A dash. Then from A dash to F dash and F dash to A dash with a thin line that is between A dash F dash, F dash E dash and E dash D dash is only these three sides will be in thin line. Now, once you do that, all the exterior adjusted boundaries of the solids are visible. Then we go to the surface which is near to the observer is visible. As you are writing the front view for the third position top view, therefore as you look from the front view, the entire hexagonal surface becomes visible. Therefore, since we are already done with D dash, C dash, C dash, B dash and B dash, A dash, and then join between A dash to F dash with a dark line. Similarly, from F dash to A dash and A dash to D dash with a dark line. Now, once you do that, this is the surface which is near to the observer. Then we have from a point, if two edges are visible, automatically that edge also becomes visible. Means what? Once you have this F dash and E dash is visible point. So once this edge becomes visible, since from F dash you have two edges which is passing through. One is F dash A dash and the other one is F dash O dash. So A dash F dash is already visible. Therefore, F dash O dash is also becomes visible. Why? Because from a point, if any one of the edges becomes visible, automatically the other edge also will become visible. So therefore, it will be on dark line. Similarly, from a point, if E dash F dash is visible and E dash C D dash is visible, therefore E dash to O dash with a dark line. So this is how you will be able to analyze it. But still, we have left out with two more points. One is C dash O dash and B dash O dash. So B dash O dash is crossing the visible edge of E dash F dash. So obviously, it will not be crossing the visible edge. So since F dash E dash is the one which is visible, therefore O dash B dash will going to become invisible. Similarly, the same explanation is given for this O dash C dash because the O dash C dash is the one of the slant edges which is crossing the visible edge of E dash and F dash. Therefore, once it becomes invisible or the crossing of the visible edge will going to take place, in such a case, these two edges will going to become invisible because the the two visible edges can never cross each other. So that is what we can see here. Both P dash and O dash and C dash and O dash is crossing the visible edge E dash M dash. Therefore, this O dash B dash and O dash C dash will going to become invisible. What happens to the position of this O1 dash? As we see, the entire hexagonal surface looking from the front view is visible. Therefore, O1 dash is on that hexagonal surface. Therefore, join between O dash and O1 dash with a thick and a big dash and small dash. Since the entire hexagonal surface is visible in the third position, therefore O1 dash is also becomes visible because O1 dash is on that hexagonal surface. So this is how you will be able to analyze the problem and solve it by manually. How do I know that my problem is right? Even in the final position, you can see that C dash D dash is on XY line because that is the end which is resting on base edge, and the axis is inclined at 30 degrees to VP since it is the true inclination, and here what I have is the apparent length. So therefore, you rewrite the same sketch on the after finding the beta inclination. So how to do that? So C dash O dash, so beta inclination, so 30 degrees to VP. So since it is 30 degrees to VP and the axis is inclined at 45 degrees to HP, therefore I need to find out the beta inclination that we have found out here. And since one of the base edges is resting on HP, which is C dash D dash, and it is a hexagonal surface or hexagonal pyramid of 25 mm, and the height of the pyramid is 50 mm. Since we have incorporated all the data which was given in the problem to find the solution, and hence our problem is right. Thank you.